This is the Azure 3.3 inch commercial refrigeration evaporator fan motor. Now, out of the box, this motor will work in most applications. It's dual voltage, 115 or 230. It spins at 1550 RPM, and the rotation is counterclockwise as viewed from the lead end. However, if that rotation or speed is not applicable to your application, you can use the wireless programming module to change rotation and speed anywhere from 600 to 2000 RPMs. But in this demonstration, I want to show how the motor can actually act as a two-speed motor with the optional thermistor kit. The motor has the capability of slowing down when the refrigeration cycle is off and speeding back up when the refrigeration cycle comes back on again. And this can be done simply with the addition of the thermistor kit and the wireless programming module. No external controller is needed, so it's very easy to install. Installing this motor in a two-speed application is really quite simple. The motor that has the thermistors attached is called the master motor, and then you can attach up to 4 slave motors, giving you a total of 5 motors. And the slaves don't have to be programmed. They will follow exactly what the master does, and they know exactly what the master is doing because all the motors will be daisy-chained together using the integrated communication harness. So you'll install each motor, plug in each power plug, and then attach the communication cables together. When the motor is set up for two-speed operation and the thermistors are installed as shown here, the motor will actually respond to temperature differences as sensed by these thermistors. There's 2 places to install the thermistors. One could be in the airflow, one in front of the box and one in back of the box. The air coming out will be colder than the air going in during the refrigeration cycle, so the motor would sense that and then run at the high program speed. And then when the temperatures become more similar, the motor decides that the refrigeration cycle is off, and the motor will then slow down to the programmed low speed. The other place to install the thermistors would be on the refrigerant line on either side of the expansion valve, and the same effect can be achieved. Okay, right now the thermistors are at an equal temperature. Let's see what happens if a thermistor fails or if we lose a thermistor. The motor defaults to its high-speed setting if a thermistor is lost, and it will simply become a single-speed motor at that point until a repair is made. But this would prevent the motor from running too slowly and perhaps freezing the coil. Let's set the motor up for a two-speed application. Now I have it powered up on the bench. I've got the wireless module attached. We'll go ahead and power that up. The thermistors are connected. So we'll open up the Azure app. We'll scan for the wireless module. Now the phone is connected to the wireless module. So next we have to connect the module to the motor. It asks if we've got thermocouples connected. The answer is yes. And now we're connected. So we could either read the parameters or we could actually go into the programming mode. I'm going to go into the programming mode right now. And I'm going to type in 2000 for the RPM for high speed and 600 for the low speed. And in this example, I'm going to use a temperature differential of 3 degrees. And I'm going to touch write parameters. Motor stops as it accepts the new program, and now it's operating as a two-speed motor. We can touch disconnect the motor, device disconnect, OK. Turn off the module, remove power to the motor. That's important because it will set the program into the motor. And then finally we will disconnect the phone from the module. And we're done. Okay, we've got the motor all programmed. Right now it's running at low speed, 600 RPMs, because the thermistors are at an equal temperature state. When there's a temperature change, the motor will speed up to the high speed. You can simulate that with this cold spray here. And you can see the motor is now speeding up to high speed